In this diary, we will complete signal and systems. So be with me and enjoy. Topic 5. Properties of impulse function. First property, del of alpha t is equal to 1 upon mod alpha into del of t. We can also say it in this way, del of alpha into t minus t naught is equal to 1 upon mod alpha into del of t plus minus t naught. This is known as scaling property. And please also remember these, that is integration minus infinity to infinity del of t is equal to 1, and similarly minus infinity to infinity integration del of t plus minus t naught is equal to 1. Now second property, x of t into del of t is equal to x of 0 into del of t, and we can also say it like this, x of t into del of t minus t naught is equal to x of t naught into del of t. This property is known as product property. Now third property, integral minus infinity to infinity x of t into del of t dt is equal to x of 0, and we can also say it like this, minus infinity to infinity x of t into del of t minus t naught into dt is equal to x of t naught. The name of this property is shifting property. We have to take that point at which the impulse lies. Note in product property as well as shifting property that del of t means the impulse lies at t is equal to 0. So we have taken x of 0. At del of t minus t naught means the impulse lies at t is equal to t naught. So we have taken x of t naught. So note this point. Now fourth property, minus infinity to infinity x of t into del single differentiation of del, that is del single differentiation of t into dt is equal to minus single differentiation of x of 0 as shown on the screen. This property is known as differentiation property. Now note this point. Whenever solving questions using this property, see scaling first, then move to product property, and if there is integration then you have to move to shifting property, but always see scaling first. Now let's see a question. Y of t is equal to 4t square del of 2t minus 4 as shown on the screen. Now see its solution. Let us see the scaling first. So 4t square into del of 2 into t minus 2. Here the scaling factor is 2. So using the scaling property we can write it like this as shown on the screen. Now we will see the product property. So using the product property we can write it like this, as the impulse lies on t is equal to 2. So answer is 8 into delta of t minus 2. Now let us see the next question. Integration minus 2 to 4 t plus t square into del of t minus 3 dt. See, here there is no scaling, but we can see the integration there. So we will use shifting property. Impulse lies at t is equal to 3. So now we have to check whether the impulse lies between the limits or not. So it lies between the limits, as the limits are between from minus 2 to 4. Now apply the property and we will get the answer as shown on the screen. Now observe this question carefully. See, here the impulse lies at t is equal to 6, but 6 does not lie in between minus 2 to 4, that is between the limits. So the answer will be 0. Now let us see another question. The question is as shown on the screen. Here it is del of dash t, that is single differentiation of impulse signal. Using differentiation property, here xt is e to the power minus 2t. So using the property we get minus x dash 0. So we will get the answer, that is 2. Now let us see what happens actually in differentiation property. See, whenever we transfer this differentiation sign to x of t, we get a negative sign outside. So now using the shifting property, we can easily write the answer as shown on the screen. See, this is just a way to understand this. Thank you. This is enough for this topic.